Hello all, welcome back to Engineering Economic course. We were talking about cost estimation techniques. In our previous lecture, we talked about an integrated approach for developing cash flows for different project alternatives, because in engineering economy, we make decisions for probable future outcomes. And since we don't know what will happen in the future, for sure, there are uncertainties, then we need to estimate the costs and revenues. And we have seen an integrated approach which had three basic components. The first one being the work breakdown structure. The second one was the cost and revenue structure, and the third one was the estimating techniques. And in this lecture, we will talk about some cost estimation techniques. Simply, we will learn the index technique, the use of indexes, and we will learn the unit technique in this lecture. So let's get started. The first estimation method that we will discuss is the called use of indexes. Simply indexes. What is an index? So usually the prices of items vary with time, usually increase with time. And what is the reason of this change or increase? It can be technological advances, new technologies may arise and these may change the prices. Or it can be the availability of labor and materials in the market. If from time to time this availability changes, then the prices also changed. And another reason is the change in the consumer buying patterns and prices, and which we will call inflation. Because of these changes, okay, we can make a ratio of one time period to another time period, the average costs or prices in one period, and its ratio to average costs and prices in another time period. And we can use this number as an quantity, as a ratio, as an index to find or estimate the values in a later time. So in this sense, an index is a statistic. It's a dimensionless number. It is a multiplier, okay? That is designed to help to compare price changes with respect to a base year. So we know the index in a base year. We know the index in another year. So if we know the cost of an item in this base year, then by using the indexes of the base year and the current year or the target year, we can simply calculate an estimated value of the cost of the item. Okay, so a price index in this sense is an average of prices for a given class of goods or services in a given region during a given interval of time. This is a general definition of an index. Of course, at this point, you may be confused, you may not be well understood, but please wait for the example and it will be very clear. It is easy to understand. So, with notation, with mathematical equations, we can represent the idea in this way. Let this IN is an index for some current year N. Okay, this is an index of year N. Simply, you can think about this as a number. For example, we are currently in year 2021, so we can say that I 2021, this is the average of the prices in 2021. And what I say as the average of the prices, average of what? Price of milk, price of cheese, price of oil, price of rents, price of insurance. So what we need to include here? Of course, these index should include the average prices related to what we are trying to calculate. For example, if you want to calculate the price of oil in a year, then you should consider the index related to oil prices. Okay, you shouldn't include the price of milk and etc. in there. But in fact, if it is not available for some specific goods, then you can use the general price index, which includes everything. Of course, it's not possible to include everything in a price index, because how many commodities, how many goods and services you have? Can you take the average of all of them? Of course, it's not possible, but you can take a large sample and make an average of them and make use of it. But you can simply think about this. When I say the index in 2021, it is the average of the prices. And if, for example, this is, let's say, 50, so we say that the average price index in 2021 is 50. And let's say there is an index for some base year K. So you can say that the price of something or the index price in, let's say, 2010 was, let's say, 45. So what happened from 2010 to 2021? The price index increased from 45 to 50. Okay, now if, let's say, I want to calculate the price of oil in 2021, so which I will represent it by the cost 2021, and I want to calculate this. But what I know is, I know the cost of oil or petroleum in 2010, and let's say this is $30 per barrel. Okay, then how can we calculate the cost of oil in 2021? Simply, we do this. If in 2021 the cost is in 2010 the cost is this much, then in 2021 what will be the cost? So this is a direct relation, and simply in order to find this, we multiply these two and divide it to this one. Okay, so the cost in 2021 is equal to the cost in the base year multiplied by the ratio of the indexes in the current year or target year divided by base year. Okay, this is simple formula, and this is the idea of using a price index to estimate the cost of something in a target year. So how do we find these price indexes, or from where we can get these price indexes? For example, in construction industry, usually cost indexes are published each year, okay, in order to facilitate these cost estimators. There are some large consultancy companies, and they can have their own cost indexes. Also, the governments may announce price indexes or cost indexes each year. So from these sources, we can obtain the price indexes. So this is an example from your book, and let's see how we can make use of these price indexes to estimate the cost. So in this example, it's said that there a certain index for cost of purchasing and installing utility boilers is key to 1988, where its baseline value was arbitrarily set to 100. Okay, in 1988, this is base year, and the price index is set to 100. There is a company which installed this capacity of boiler in 2000 for this price, when the index had a value of 468. Okay, in 2000, the index was 468. Let's collect the data, what we know. Index 400, index 2000 is 468. Also, we know this index 1988 is 100. Okay, then the cost of the boiler at 2000 is $525,000. Okay, this same company must install another boiler of the same size in 2017. Okay, the index in 2017, we know the index in 2017, which is 542. And what is the approximate cost in 2017? Okay, we want to find this. Of course, when you look at this one, this is an unnecessary data. You don't need to use it. We need to know the index in 2017. We need to know the index in 2000. We know the cost in 2000, and we can find the cost in 2017. Simply, we say this. In 2000, if the index is equal to 468, when the index is 468, the cost was this much. Then when the index is in 2017 is 542, what will be the cost here? Simply we will do this calculation, and it means that we will multiply these two and divide it to this one. So let me write it here. C 2000 cost in 2017 is equal to 525,000 multiplied by this index divided by 468, and which gives you an estimated value of $608,013. This is the estimated value in year 2017. As you can see, this is a simple method. This is an easier method to come up with cost estimates. And this is the solution of the problem. Okay, in the cost in 2017 is the ratio of indexes multiplied by the cost in the base year. You will obtain the cost in the target year. Sometimes we use indexes for just a single item, but sometimes we can use the indexes for multiple items. For a single item, the index value is just simply the ratio of the cost of the item in the current year to the cost of the item in the reference year and multiplied by the reference year factor. But sometimes we develop or create composite indexes. And the composite index is simply created by averaging the ratios of the selected item costs in a particular year to the cost of the same item in a reference year. And in order to calculate these averages, sometimes we may assign different weights to the items in the index according to their contribution to the total cost. So different items may have different contributions to the total cost. Okay, for example, there are two similar items A and B. Okay, these are similar items, but we are using 2 times more A than B. Then if we just take their average price, we are giving equal importance to these items A and B, and it's not correct. So if we are using item A 2 times than B, then we need to take the average accordingly. We need to weight the items. So this equation shows how we calculate this composite index. So assume that we know the composite index value in year K, this is base year, and we want to calculate the composite index in year N, this is the target year. Then what do we do in order to calculate this one? We take the ratio of this item 1, the cost of item 1 in year N, divided by the cost of item 1 in year K, multiplied by the weight of this item. Okay, as I told you, if there are A and B items, then in this equation, simply we will make the calculation for A and B, and since A was 2 times more important than B, then simply, according to this calculation, we will do this. 2 times, let's say, cost of A in year N, okay, divided by cost of A in year K, plus the weight of the item B will be 1. Okay, we can just say that because we are saying that A is 2 times more important than B, that's why we are using 2 and 1 here. So the cost of item B in year A divided by cost of item B in year K, and we divide this whole thing with the sum of the weights, which is 2 plus 1. Okay, this is the summation of the weights, and we multiply this by the index in the base year, which is IK, and by this way we obtain the index in year N. So in this calculation we have in total M different items. Okay, M represents the total number of items in the composite index. WM represents the weight assigned to the mth item. So W1 is the first item of the first, weight of the first item, W2 is the weight of the second item, and etc. So these are the costs of the mth item in year K and N, and this IK, as I told you, the composite index value in year K. Now let's consider this example to understand this composite index better. So we have this data given in the table. Based on this data, develop a weighted index for the price of gallon of gasoline in 2017, when 2016 is the reference year, having an index value of 99.2. Okay, in year 1996, the index value is 99.2. The weight placed on regular unleaded gasoline is 3 times that of either premium or unleaded plus. Okay, because roughly 3 times as much regular unleaded is sold compared with premium or unleaded plus. So it means that this regular unleaded, if the weight of this item is 3, then the weight of this item unleaded plus is 1, and the weight of premium is also 1. Now here we want to establish a composite index for year 2017. Then how do we calculate it? Remember, we want to calculate this index in 2017, and simply it will be the weight of the first item, which is 1 times the cost of the first item in 2017, which is 272, divided by the cost of the item in the base year that we know the index, which is 114, plus the second item, weight is 1, and the price or cost in the target year is 2058, divided by the cost in the base year, plus the third item, weight is 3, and the cost in the target year divided by cost in the base year, divided by the sum of the weights, 1 plus 1 plus 3. Look, when we say the weight of this item is 3 times more than the others, we decided to use weights as 1, 1, and 3. But in fact, if you like, you can use 2, 2, and 6, because 6 is 3 times this and 3 times this. And nothing will be changed, because what happens, instead of 1 here, you are writing 2, 2, and 6, and then here you are writing 2, 2, and 6, and you will obtain exactly the same result, because in this way you are just multiplying every coefficient by 2. Okay, so then it means that you can use either one of these. Okay, and what we need to do is we need to multiply with the index of the base year, which is 99.2, and from here you will obtain the index in year 2017 as 251. Now let's assume that someone gave us this index value in 2019 as 297. Okay, so this is the end of the question. Actually, we calculated the index, but now we are adding some more detail into this question, and assume that the index in 2019 is given to us. Then what will be the cost for each one of these items in 2019? So what will be this value, what will be this, and what will be this? How can we calculate these? Of course, we will simply use the indexes and the costs of the items. You can select any one of these years as the base year, because we know the costs of the items in each one of these years. But if you already know, or if you know the cost of an item in a more recent year, your estimation may be more accurate. Therefore, instead of using 1996 for this estimation, it is better to use the cost in 1917. And for this one, when we want to find the cost of the premium gasoline, so the cost in the base year is 2072, so I'm simply selecting 2017 as the base year, and the cost is 272, and I need to multiply this with the index of the target year, which is 2097, divided by the index in year 2017, which is 251, and by this we calculate it as 322 cents per gallon. Okay, so this is 322. Similarly, for unleaded plus, we do the same calculation and we multiply the cost with the ratio of the index in these years, and we obtain 305 cents per gallon. And for the last one, regular unleaded, we multiply this cost in the base year with the ratio of the index, and we obtain 285 cents per gallon. Okay, so in this example, what we did, we learned how to calculate a composite index, and then we learned how we can use this composite index to estimate the values of multiple products, multiple items in a future year. You can see the whole solution of this example here. We first calculated the index in year 2017. This is the composite index, and for this we used the index of the base year, which was 1996, and then in order to estimate the costs or the prices of each one of these items, we used the price index in 2017 and the cost in 2017 and the price index in 2019, and we estimated the costs of each one of these items. The second technique, estimation technique that we will talk about is the unit technique. This unit technique involves using a per unit factor that can be estimated effectively. For example, the capital cost of a plant per kilowatt of capacity. Okay, if you know the capital cost per kilowatt of capacity, and if you want to establish, let's say, a plant with, let's say, 2000 kilowatts, okay, then simply you multiply this per unit cost per kilowatt capacity with this total capacity to estimate the total cost value. Or, for example, the operating cost per mile. If you know the operating cost per mile, and if you will transport for, let's say, 100 miles, then you can just multiply this per unit cost with the total distance to estimate the total cost. Construction cost per square foot of a building, of a construction project. Again, if you know this per unit cost, then depending on the square meter or square feet of the construction project, you can calculate this. Again, you can do this for different things: revenue per mile, capital cost per installed telephone, revenue per customer served, and etc. Okay, you can use these per unit costs or revenues to calculate the total cost or to estimate the total cost. Okay, a per unit factor is used along with the appropriate number of units to find the total estimate of cost. And this technique is one that's widely known and understood. It's easy. Let's solve an example to understand it better. So assume that in order to construct a house, the per unit factor for square foot is $120. Okay, constructing a house with 1 square foot, let's say, is $120. And if you want to construct a house with 3000 square feet, then what will be the total cost? Simply, it's the per unit cost multiplied by the total square feet. And then you will estimate the total cost being as $360,000 in total. Okay, so this technique is useful in making preliminary estimates when, for example, a client asks for a ballpark figure of probable cost of a project. Of course, the real value may be different than this one. It's a rough cut estimate, but it is easy. Of course, how you find this number is also a problem. Okay, when we say what is the per unit cost of constructing a house, how can you come up with $120? Of course, it's another issue, but once you get this number, then estimating the total cost is easier. As I told you, sometimes using such average costs can be very misleading. Okay, so this is the end of this lecture. In our following lecture, we will continue to talk about some more cost estimation techniques.